everybody. So we're going to look at binary numbers today, but what I'd like you to do first is I'd like you to pause this video now and answer these questions. Okay, welcome back. So I hope you took a look there and seen what hexadecimal numbers are and do computers ever use them. Okay, so we're going to look through this during the lesson. Now, so we're going to look at number conversion, lesson 1. So you're going to convert numbers from one number system to another number system. Now, so you're going to convert binary numbers to denary, and denary to binary. Some of you may remember doing this in year 9, okay, but we're going to go a little tad deeper, okay, and as the lessons go on, go even further in. We're going to show the understanding of the basis of different number systems, and we're going to use binary, denary, and hexadecimal number systems. Okay, so how can numbers be represented? Now, sorry, I just moved the microphone over because there's a lot of noise outside there. So they can be represented this way. So if we take a look at this, when we hold our fingers up, okay, so we can see there's 5 fingers. And then we can look on a domino and see that these dots represent 5. In Roman numerals, this is 5. Then you've got a deck of playing cards, you've got the 5 of hearts. And this will represent 5 here. And then, of course, there's the number 5. Now, it's all numbers are is basically a way to represent the amount of something. Okay, so we understand it. So numbers are just simply a representation of, say, you know, mass and volume. So like, for example, we make sense of something. So if we go, oh, it's hot outside today. Oh yes, it's 30 degrees. And to some people, 30 degrees don't mean anything. They like to convert it into Fahrenheit, okay? So numbers are just a way for us to represent something, to understand. Now, what is a number? So, as I said, it's maths. It's a mathematical object used to count, measure, and label something. We use numbers to give us ideas of the quantity of something, and the numbers are just the symbols to represent that. That's all they are. And here's some examples. Okay, so weighing scales, like you may think, oh, I feel I'm a bit heavy and my diet's not been good. I've put on some weight. Then when we step onto the scales, then we understand whether we've put on as much as we think we have, or is it that bad? Then, you know, so when you look at something like the BMI chart, sometimes they don't mean a lot to some people because, for example, if somebody is a bodybuilder and they've got a hell of a lot of muscle mass, a BMI chart may say that they're morbidly obese. Then we can, you know, like I said, we can say it's hot outside, and you look at how hot it is outside or how cold it is. Then when we look at the numbers here on this thermometer, so when the mercury goes up here, for example, we've got 30 or we've got 80, then that's how we understand how hot it is outside. And then the mass of weight, oh, that's really heavy. Well, it weighs 2 kilograms, you know. So, you know, that's all numbers are. That's all they are. We just make sense of our world using numbers. So if we take a look at these symbols here, for example, so we know numbers. We know between 1 and 10, okay? But look at the balloons here that you see. So we understand there's 0, then there's 1 balloon, then there's 2 balloons, then there's 3. Then when it goes past 9, what we do to represent the symbols is we simply add a 1 to make 10, then a 1, 1 for 11, then a 1, 2 for 12. So the numbering system we use, going by that, is something called the base 10 numbering system, okay? So this is our base 10 here. So for example, if I was to take away these numbers here, that would be 5,352. But then we use the decimal points to represent the smaller values. Okay, so like we've got our whole numbers there, then we've got our decimal fractions. And they go in thousands, hundreds, tens, and ones. okay? So that is how it's a base 10 numbering system, okay? Because then we get a 1 here, multiply that 1 by 10, then we're in the tens. So then, 0 then turns into 10, for example. Then we get our hundreds, so then we multiply that again into the hundreds, then we multiply that again into the thousands. Then we've got our decimal point, and we've got our tenths, hundreds, and 10,000ths. So this, what would happen is when you get a whole number and you divide it by 10, then it becomes a fraction. So for example, you've got 1 cake, and then you divide that cake by 10, you take a piece of the cake, you've got 1/10 of the cake. Now, putting the numbers in their place for the base 10. So this is how we understand the numbers in very simple terms. So for example, when you was in primary school, your teachers would have taught you how to add up and divide and so on. So here we've got, sorry, I go back to that here. So we've got 0, add 1, okay? And there we go, to make that 11, okay? So we got, then here, for example, we've got 99 add 1. So how do we do that? Well, what we do here is 9 add 1, you make 10. But you can see I put the 0 down there to carry the 1, and you carry the 1 over here. So now this is going to become 10, isn't it? Because it's 9 add 1. So then you put another 0 there, and you carry the 1 over here, okay? Now that's just simply 1, add 1, and then we place it here to make 100. So that's how we understand our base 10 numbers. Now, what are binary numbers? Okay, so these are base 2 systems because all the numbers are represented are 0 and 1. So a computer only knows 2 things, it knows 0 and 1. And then what the computer does, it makes sense of those zeros and ones. But remember something, a computer only knows what a human tells it because they were invented by humans in the first place. So what you can do is you can make a table like this. If you want to do this with pen and paper now and follow it, please do, or follow the video. Okay, so this is how we make the table. So to make the table, all you do is keep doubling it. So you go 1, 2, 4, 8. So you just keep doubling. Now to make the number 5, you place the 1 under the numbers that you know are going to make 5. And then the ones that don't, you just put 0. Okay, so as you can see here, 5 is 1, 0, 1. Okay, but we read it backwards, all right, because we go 1, 0, 1. So what you do here is you just simply get the 1, add 1, yes. Do I add 2? No, because there's a 0. Do I add 4? Yes. So that makes 5. Do I add any of these? No, because there's 0. Okay, so this is binary. Now, this is how the binaries are positioned for those of you that are very mathematically minded. Okay, so you just keep multiplying. 2 times 2 times 2 is 8. Okay, so now 5 is 5 for us, but for the computer, it's 0, 0, 0, 0, 0, 1, 0, 1. Okay? But we as humans can forget the first few zeros and we can represent 5 as 101. Not 101, 101. Right to left. Okay, so for task 1, I'd like you to convert these using your table. Okay? So I'm just going to share another screen with you. I'm going to do a new share. And this is, now you can click on this on, here it is. So you can click on this if you want on Google Classrooms, or you can click on a link underneath the video. Okay, so like you've got denary here, so you've got 3. Now you need to make that. So how we make 3 is we just simply get here. Does 1 go into 3? Yes, it does. Does 2 go into 3? Yes, it does. Now we've made 3. We know the rest of these are 0. I wouldn't put 0 there. I'd just leave it. So the answer is 1, 1. Okay? Then the same for 2. Does 1 go into 2? Yes, it does. But we know 2's next. Okay? So the answer would be 0, 1. Okay? Right. Pause this video now and complete task 1. Welcome back. Let's move on. Okay, so I'm assuming that you've completed the task. So I'm going to share my new screen with you. Okay, here are the answers. So I'd like you to assess your work. Okay, pause this video to assess your work. Welcome back. Now, scientific way. So another way is if we was to divide the position to the remainder digit, it must be 0 or 1. Okay, so this is another way that you can convert it. Okay, so I personally don't like this way, but other students have seen it and it makes sense and they use it. So this is the way you're going to, remember you're working from right to left. So we're going to convert the number 246 to binary. So 246 divided by 2, okay, equals 123 with a remainder of 0. Then if we divide it by 2 again, so we divide 123 divided by 2 is 61, which is 61 with the remainder of 1. Because I think there's a partial number. So then, there is one number left over. Sorry, I'm being silly. Okay, then if we get 61 and divide that by 2, it's 30, remainder of 1. Then if we get 30 and divide that by 2, it's 15 with a remainder of 0 at that stage, because obviously the 1's gone, it's completely gone. You don't carry the 1 over, okay? So 15 divided by 2 is 7 with a remainder of 1. 7 divided by 2 is 3 with a remainder of 1. Then 3 divided by 2 is 2, remainder of 1. And then 2 divided by 2 is 1 with a remainder of 1. Okay? So then, working from right to left in binary, okay, we're going to put this, so that would be 0 there. Okay, because what we're doing is, sorry, need to explain this to you. We're going to get all the remainders here. This is what makes the binary. Okay? So I'm going to continue to do that. So remember, right to left, so you can see what I'm doing there. So all these remaining numbers then become the binary. You can see that I'm crossing them out as I go along. Okay, so 246 in binary is 0, 1, 1, 0, 1, 1, 1, 1. And you can check that using the methods that I gave you earlier. Right, so as you can see, we're moving on to task 2. So you're going to convert the worksheet. Now I'm going to do a new share for you so you can see the worksheet for task 2. So you can download this from Google Classrooms or click on the link underneath the videos. So what I'd like you to do is test out that method, okay? And I'd like you to convert these numbers into binary, or you can use the other methods that I've given you. The idea is I don't want you using the table if you don't have to use it, okay? Right, pause this video now and complete the task. Welcome back. Let's move on. Okay, so I'm just going to share my slides again. Now we're going to look into hexadecimal. So if you'd have completed the task earlier, you know that computers, and also, even if you didn't complete the starter task, you know that hexadecimal isn't used by computers. It's simply used by humans to make long, complicated numbers easy for us to read. And it's used particularly among networking managers. So a hexadecimal number is a base 16, meaning we multiply everything by 16, okay? It's a representation of 4 binary bits represented by 16 numbers and letters. Okay, so we use numbers 1 to 9, just the same, but anything after 9 then becomes a letter, okay? So numbers 10 to 15 are represented by letters. So if we were to say, what is 10 in hexadecimal? It is A. Okay, so there you go, there's the table. So you can see here, everything is normal, okay, up until we get to number 10, when you can see it then becomes letters. So how do we convert hex to binary? Okay, so to convert a hexadecimal number, we need to treat every digit separately and convert it to a 4-bit binary. Okay, so for example, we know F is 15. So 15 in binary is simply 1111, and that's it. Okay, so what you're going to do now is you are going to convert a hexadecimal into 4 bit binary numbers, and then denary and vice versa. Okay, so for example, 14 would be E in hexadecimal, and in binary, right to left, remember, 0, 1, 1, 1. Okay, I'm going to show you the worksheet now. It's not hard to do, believe me. Here we go. Okay, convert A into binary. So we know A is equal to 10. Okay, so we know that. So what we would do then is convert that into, yeah, you might have to do it up here actually rather than use the boxes. Okay, oh sorry, denary's 10 there, and convert it into binary. Okay, so we know that. Right, okay, very best of luck to you. If you need any help, please leave a message on Google Class on Hangouts and I will give you a hand, okay? So very best of luck to you.